Good evening and welcome to this evening's BCS Mid Wales branch webinar. First of all, some usual housekeeping announcements. This presentation is being recorded and will be available on the BCS YouTube channel in due course. During the presentation, please turn your microphone and camera off. You're welcome to turn them back on after the presentation for the question session. Also, you can put questions into the chat during the presentation, and then we'll try and read them out after the presentation. So it's my pleasure to introduce Dr. Patricia Shaw, who's going to give the presentation this evening. Patricia is a lecturer in computer science at Aberystwyth University, and she specializes in robotics. Patricia has been coordinator of the Intelligent Robotics Research Group for the last 5 years and introduced the annual Aberystwyth Robotics Week, which runs at the end of June every year, to engage with the general public about robotics and the latest research. And in fact, our next BCS Mid Wales branch event is associated with this year's Robotics Week. Our event is on the 21st of June. So over to you, Patricia.
Thank you very much for that introduction. I'll just bring up my slides now. There we go. So thank you very much for the introduction today. What I will be talking about is specifically focusing on the robotics clubs, my engagement with the robotics clubs, and how we can actually use those robotic clubs and see them as a platform and the use of robots for informal education, and specifically looking at the opportunities for overseas development, looking at an example project where we've been establishing a robotics club over in Iraq and the potential benefits that can come with that. So I'll start off by introducing the Aberystwyth Robotics Club and giving you an overview of that club, and in particular focusing on the beginners section of that and the curriculum that we've developed for the club, before moving on to looking at the club that we've been setting up in Iraq and some of the complexities in doing so, but also some of the educational and socioeconomic benefits of doing that. And I'll just finish off with some plans of what we've got for in the future in terms of how we're planning on linking everything together and the additional benefits we can get from having distributed clubs. So to begin with the Aberystwyth Robotics Club, it was actually established by techno camps when they formed in 2012. And it started out as a techno club to try and get kids interested in technology in general, from everything from programming, electronics, hardware. And when they moved away, so at the end of the first round of projects which finished in 2014, the club actually continued on as an independent entity run by Steve Fern, who I believe is here today with us, and was established as the Robotics Club. And that club recruits school children, typically years 7 and 8 onwards, from local secondary schools in the area, and is able to run on a weekly basis, introducing the kids to robots, to programming, and some of the design skills they need, and then continuing on. And over the years, we've had approximately 80 students in the last 8 years actually make their way through all the way up, and now have actually gone off to university to study STEM subjects in various different places, which is a really nice output from the club. But we don't just run the weekly workshops, we also run various workshops throughout the year aimed at the public. So we run various things like pumpkin hack, Christmas card hacks, aimed at quite a young audience to get them interested in very basic, simple programming, building up little electronic circuits to light up their pumpkins and Christmas cards, for example. But the Robotics Club has also been responsible for coordinating the Beach Lab events, which have been very successful over the last how many years they've been running them for, and generally down the seafront. So you do see the robots that have been built. There's the entertainment robots developed by Steve Fern, as well as many of the robots developed by the children in the club. And some of the research robots are featured alongside that, and that's been incorporated within the Robotics Week that Fred just mentioned. So focusing mainly on beginners, over the duration that the club has been running for, they've actually formed a 2-year curriculum for the beginners that covers a range of different topics in a series of round robins that, from an educational perspective, essentially follows a spiral curriculum whereby they introduce the topic, they cover it in quite a simple form, but then they'll come back round to it and cover it in a bit more complexity, which gradually builds up competence in those skills over the duration of that 2-year curriculum. When they finished, graduated, if you like, from that beginners club, then they are able to move on to intermediate and advanced groups, where they're introduced to things such as CAD design and actually designing their own electronic circuits and cases and 3D printing of those casings. And that tends to be in individual projects that they propose, the things they actually want to work on themselves. And it's then supervised on much of a one-to-one basis, but they're given pretty much free rein to design and develop their own robotic applications. And we have had some really nice ones, ranging from the reproduction of various robots from Red Dwarf through to weather stations and monitoring systems like that. So there's really quite impressive outputs that come from that. But I'll be focusing on the beginner curriculum. I just want to quickly talk you through what that curriculum actually covers and the various round robin projects that they work on over that 2-year period. So one of the very first things we actually get the children to do is learning to solder. So some of them may have done a bit of soldering before, but for most of them, this would be their first opportunity to have a go at soldering a circuit. And so we actually take them through the process of, we give them a kit, diagrams and instructions on what goes where, and introduce them how to solder safely. And this is very much a one-to-one supervision activity, so we have to be really quite careful in order to make sure that none of the children get injured, because these are typically year 7 students, so you're looking at 11 to 12-year-olds. And over the period of 3 to 4 sessions, they actually solder up, or learn how to solder and wire up and solder one of these circuits. And it typically runs just before Christmas. So last year we had them soldering up this Christmas tree, which made quite a nice decoration for them to hang on their trees in time for Christmas. Alongside that, so in order to sort of reduce the number of students in one group whilst we're doing the one-to-one soldering, then we also have a playful coding, which is developed by Hannah D as part of other projects, where we introduce them to some very simple Python programming. But actually one of the main things we're interested in isn't so much the programming, but the algorithm design and consideration of what's involved with writing programs from an algorithmic perspective. So as part of this, they are given essentially a complete program, which they then we talk them through how to modify that. But we try and get them to think about how to get objects like raindrops falling from the top of the screen, and how to then detect collisions between those drops falling from the top, and how to then actually detect a collision with an object. And specifically the object here is a face. And we do talk about what the face detector is looking for, and they have a go at drawing out on paper faces in order to try and fool the face detector, either recognizing it or not recognizing it, and what's the simplest form of a face that it will actually recognize. So actually trying to get them to understand what's going on behind the scenes and how that works. And even things like for the falling objects, rather than having them falling from the top of the screen, if you wanted to have them go across the screen, and how to go about doing things like that. So it's very much about getting them to play, but also think about how computers work and how algorithms can be defined. Following on from that, we do get to start building actual robots, and we start off with the Lego Mindstorm robots. So they're given the bare pieces, they're given instructions to build up a particular model, and then they go through the process of actually constructing this robot. So it is the first robot they actually get to build. And once they finish building it, They then have various programming challenges, and those of you familiar with Lego Mindstorm will be aware of the block-based programming languages that they use. So it's quite a nice, easy representation for them to get to grips with, and they can very quickly actually get it to solve challenges, like, for example, using the line sensor to follow a line, using the ultrasound to avoid obstacles. And for a bit of fun, we then get them to sort of extend their robots and being able to do sumo robots, so fighting around a ring where there's a line around the outside which marks the edge of the ring to avoid using the line avoidance, but also using the obstacle avoidance to actually detect now the other competitor and charge towards them. So trying to autonomously do some sumo robots, although quite often it turns into more of a remote control robot battle. But as long as they're having fun learning something, then that's actually the main benefit from it. Moving on from the Mindstorms, we actually start to build up the complexity, if you like. And so at this point, we actually go on to these Valiants, which are reconditioned robots. Inside, they're actually Arduinos that have got ultrasound, LDR, so light sensors on them. They've got speakers and various other sensors in there so they can drive around, sense the environment. And so we actually provide a library for them to program these robots that gives basic instructions like go forward, turn left, turning the servo. But they also can play music, which on the run up to Christmas also gets particularly noisy. We get them to get the robot to play a song and dance along to it. So they've actually got to think about synchronizing the sound, the music that they're making with the movements of the robot, which is quite a nice challenge for them. And they get to decorate the robots as well. The covers on these Valiants are replaceable, they're easily removable and can be quite easily cleaned up as well. So it's a nice challenge there to finish off with them, but you can do other challenges with them. So again, we take the principles of the line following that they've been doing from previous exercises with the Mindstorm and see how they can actually apply that on a slightly more sophisticated robot. So this has gone from the block-based programming of the Lego Mindstorm to a text-based C language, but with a lot of predefined functions that actually make it much easier to make that jump. Moving on from there, we actually cycle back round to building another robot, and this is using a Magician chassis where they have to wire up so there's an Arduino on there, there's motor controllers on there. This one isn't showing any of the sensors that are then attached to it, and quite often at the end when they finish adding on all the sensors, it becomes quite a wiry mess with soldering all over the place, because they do need to solder wires together in order to be able to connect everything in. But they are actually they've now gone from the Lego Mindstorm where they're connecting blocks together to actually connecting motors directly to wires to other connectors in order to be able to build up this robot. And so this is making use of the soldering that they were using, that they'd done previously, and generally building up the robots. And once they've finished building this, then it's programmed in a much similar way to the Valiants, except without the library this time. So rather than giving them the set of library and instructions for being able to drive the robot around, they now have to write those themselves. And so they have to learn how to control the motors, how to control the servo. And with that, they can then actually use the sensors, use the obstacle navigation to do tasks like maze navigation. So we've got a maze set up for them where they can actually work out an algorithm that makes use of the servo for the ultrasound, drives the robot and is able to successfully navigate the maze. Not always as successful as we might hope, but they do tend to get there eventually. Once they've got the hang of that, then we move on to, if you like, almost the next level of complexity in some regards, and we start to introduce them to a Raspberry Pi. And this opens up a lot of different opportunities for different programming languages and different things that we can do with them. So obviously we're introducing them to a bit of Python, but we can also introduce them to a bit of web development here as well. So we have had them making their own web pages with a bit of PHP programming in there. And you can also connect some hardware up to the Raspberry Pi in much the same way as they were doing with the Magician chassis. And so what we have done in the past with them, and we do a range of different challenges here, is actually have them from a web page controlling some LEDs connected to the board, for example, to send messages in Morse code, or we did even do a Braille one, which using lights for Braille is an interesting application, but perhaps not necessarily the most useful. But they certainly enjoy it, and it's a good challenge for them, and it gets them thinking about how everything connects together. One of the things we are very keen to promote within the club isn't just that they learn how to do things, but they talk about what it is that they're doing, and that they promote it. And so they get used to events such as these show and tell events, where we encourage the students, some of the beginners take part in it, talking about what they've been doing, but also more of the advanced group. And you can see here at the bottom, Rowan's talking about her scooter robot. And you can make out some of the other robots just about that have been developed by the advanced group in terms of the projects that they work on independently. And we also run a sumo bot competition there. And so there are various competitions, there's prizes awarded, and those prizes tend to be related to commitment, development and innovation for the students within the club. So it's definitely something that's there worthwhile and getting involved with. And it's not just the show and tell events at the Beach Lab. They also get an opportunity to talk to the general public now about what it is that they've been doing. And you can see quite a few of the robots from the club in the middle. So there's various cyborgs there, some humanoid robots, there's a laser heart, and various other chassis that have been developed by advanced group members. And it's really an opportunity for them to come and talk to the general public. But we also have some of the beginners showing off the projects that they've been working on. So we're very keen on actually getting all of the different aspects through from the club. And what I want to move on to now is actually how we can use that to perhaps help with technological and social economic development in overseas. And specifically, we recently had a project involved setting up and establishing a robotics club over in Iraq at Kerbala University. Now, this came about when we had a PhD student, Mohamed Haider, who came over from the university in Iraq to do his PhD here. And whilst here, he observed the robotics club that was running, how much the kids were enjoying it and what the benefits were that they were getting out of it. And so when he graduated, he was actually really keen to try and establish a similar club back home to support the children there. And through collaboration with various people, so we've got Amelia Kirky in international politics, we've got Mohamed, we've got Stephen Atherton in education, of course Steve Fern, who's running the Robotics Club here in Aberystwyth, and myself. We eventually managed to locate some overseas development aid in specific form of a Global Challenges Research Fund that would enable us to actually kickstart a robotics club through the means of providing equipment, providing resources for them to get started. So we put in an application for funding, specifically with the aims of looking at developing the technological and innovation capacity for the young people over in Iraq. But not just the technological capacity, also looking at how the club could benefit from could support social cohesion and sustainable development. So what we're really interested in is, can we actually engage the children in technology, in robotics, in programming, in order to therefore be able to build up the skills over there and hopefully help them to develop solutions further down the line to problems, get them into the programming and development aspects. And that's all part of the capacity building for the overseas development, which is one of the main aims of the funding that was provided. And so thankfully they did give us some money to do that. And so we've actually been able to take the idea of the Robotics Club from Aberystwyth and use that as a model to try and develop a new robotics club over in Iraq, specifically looking at the benefits and challenges involved with doing setting up such a club, both in terms of the educational, financial, technical and political implications of that. And so this was just a pilot project that we were running. It consisted of 2 separate phases of workshops. But it wasn't just about getting the school children involved, it was also about getting undergraduate students involved in delivering the Robotics Club. So we weren't just looking at helping the children to get interested in technology, we were also looking at how we can help the older students, the undergraduates at the university, to really get on board and how to communicate and support the delivery of such a clubs. And so the pilot project did include training for those students as well as the staff on how to support the school children during the series of workshops. And in terms of the workshops themselves, we recruited 20 participants, 20 school children from neighbouring schools. And at the end of each phase of the project, we were intending on running a series of surveys in order to get feedback and assess how well the educational and other impacts were conveyed as a result of the project. And we were also keen to have a public robotics show and tell event for them. So for them to both locally to interact, to promote what it was that they were doing, but also potentially trying to get some of them over here to be able to talk about it and show what they've been doing. But I will talk about that some more later on. So one of the key things that we were looking at was the educational, the pedagogical approaches, and that is the theory and practice approach to teaching and learning through the use of the Robotics Club. And hopefully for the audience here, the things like the technical skills and the computational thinking will be quite obvious in terms of what we can gain from the Robotics Club. So both in terms of, from the technical side, the construction and programming of robots, through to the computational thinking, where we are looking at the algorithm design, the iterative problem solving aspects. But there was also a keen focus on the collaborative learning side. So the informal exchanging of ideas, the co-creation towards a common goal and building up relationships as a result of the club. So we were really keen to actually incorporate as much teamwork into the exercises as possible and provide them with lots of opportunities for sharing what they'd learned and for working together to solve problems, and also a little bit of competition towards the end just to give them a bit more of a push. So one of the first things we had to do was actually identify the hardware that we wanted to provide for the club. Now, as I mentioned earlier, the Aberystwyth Robotics Club was using the Magician chassis, which is a great platform. It's great for them to learn, but it does actually require the knowledge of soldering to really be able to put it together. And there's also quite a bit of checking that needs to be done before we even give them batteries to power them up, to make sure that they've not connected things in such a way that they would release the magic smoke from the electronics and essentially blow out the boards. So we were a bit nervous about providing that as an initial platform because of the complexity and risk associated with it. So instead we were having a look at various kits that were available. And that was where we came across the Elegy 4-wheel drive robot car that's very similar. Actually, it has much the same sensors on it, but the main difference is that it has a breakout board with various connectors mounted on top of that makes the wiring up a much simpler process. They essentially are able to plug and play with the various different components. So there's very little risk of it being wired up incorrectly. It's quite straightforward to build, but they still get the opportunity to actually go through the process of building up a board. They still need to position the motors, connect them to the wheels, and thread the wires through. So there are still some of the benefits there, but actually in a much safer, simpler process. And so that was what we were planning for phase 1. Then for phase 2, we were initially planning on taking slightly more towards the advanced group side, actually looking at some of the CAD design things. And so one of the things we initially planned for phase 2 was to provide them with a 3D printer, take them through the various issues related to CAD design, see what we could get them to build, perhaps building cases for the robot and so on, for them to develop their own robot chassis. One of the major issues that we very quickly encountered, though, is of course the political relationship with Iraq, and therefore there are actually export limitations on what we are able to export to Iraq. And the first thing that we actually had to do once we decided what hardware we wanted to provide was go through this military goods checker to see if we were permitted to even send that equipment out to them. And when you go through the military goods checker, you come across statements like it incorporates 2 or more closed loop or open loop servo devices. It has user accessible programming, it's reprogrammable, it's capable of positioning and orienting parts and tools. And when we look at the Elegy Robot, then, well, there are 4 motors on there and a servo. It is mobile platform, it's reprogrammable. And for the 3D printer, of course, there are concerns about the use of 3D printers for being able to print weapons. And we were quite worried actually wouldn't even get off the ground at this point. And so we did submit an application to get approval to export the robots and the printer. They gave us permission to export the robots. Fortunately, due to the size of it, they just saw it as a toy and therefore not something that fell under the restrictions of the military limitations for export, but not for the 3D printer. So we went ahead and exported, we ordered a set of 20 of the robots and got those packaged up. We did also have to get the ethics approval though, because of the project that we're running, and especially as it involves school children under the age of 18. And so that was a full ethics board approval required. Fortunately, they were a bit worried about the idea of a robot car until they saw the size of it. I've got my car here as a handy prop. And once they saw the size of it, it's actually just quite a small robot. They were much more relaxed about that. The risk assessments, because we've been running the club in Aberystwyth, were quite straightforward. There weren't any problems there. But they were concerned about the location and the fact that potentially if school children are travelling to the workshops, and the fact that the workshops were associated with the UK institution, whether that would add any additional risks to the participants in the club over in Iraq. Now that severely limited our pool for recruitment. We did get approval from high up in the president of the Kabul University for supporting the club, and confirmed that there were no concerns about being associated with the UK institution for running this, which was very reassuring. But in terms of the recruitment, we'd hoped to have quite a broad recruitment pool in order to address some of the socioeconomic issues in the area from the poorer areas around the university, but actually we ended up having to recruit from a limited set of schools essentially directly inside the university campus. They have a walled area, so it's a safe compound where many people live and also have various schools there. And so much like the club here, we ended up recruiting from very small local subset, which limited us slightly, but at least it kept things safe. So with all the approvals to go ahead, we were then able to ship the robots over there, which was for us a completely new experience, trying to figure out how to ship a set of robots to Iraq. And there was a lot of paperwork involved with this. The main risk actually was due to the batteries rather than the location, fortunately, although not many shipping companies will take it to Iraq. But FedEx fortunately do, and we were able to get them sent to there. There were some issues at customs, but actually they did arrive safely, and the first series of workshops were able to begin. So in terms of then actually preparing for the workshops, although we had a lot of existing material from the local robotics club, we did essentially need to develop a lot of new material. We were able to reuse some of it, but because we were very keen to try and make sure we incorporated the pedagogical aspects and promoting the teamwork and collaboration throughout the workshops, then, and also adapt it to the slightly different robot platform, then we did need to rework quite a bit of the material in order to incorporate that. Once written, they then needed to be translated into Arabic, although some of the children there can speak English, not all of them could, and so therefore translating them needed to be done before we could start the workshops. And recruitment was done, making sure we had 10 girls, 10 boys in the desired age group. As I say, most of the children came from the schools directly connected to the university to minimise any additional risks there. So in terms of the schedule for the first phase of workshops, we started off obviously with introducing the club, going through the risk assessment in the induction to ensure that it was all safe and they knew what to expect. And then of course they got to build the robots and started to introduce them to some of the programming side of things. So getting them to introducing them to the programming for the first time for most of them, and the Arduino, writing some very simple programs, but rapidly building up the complexity to being able to do some quite sophisticated things. And the best way to show you this is actually through a series of photos from that first phase of workshops. So you can see them building up the robots with the help of the undergraduate students there as well, and getting to grips with starting to actually program those as well. And the first exercise was the line following exercise. There's no sound with these videos. Or I should say the sound has been muted for the purpose of the presentation. But gradually building up the tasks. So these are children who'd never programmed before, they'd never used a robot before, but very quickly within a series of workshops, were able to program it to follow a line, to avoid obstacles, and gradually building up to being able to navigate around a maze as well. And at the end of the series of workshops, we actually had a competition. They broke themselves down into two groups, and the challenge was to follow a line and then actually switch behaviour to be able to navigate around a maze, which anyone involved with robotics will know it's not always easy to get them to change behaviour. One behaviour is often enough for a robot. And I can say that as the robot exited the maze, there's quite a bit of cheering going on in the video. But it was really quite impressive to see how they progressed through the challenges and successfully completed them at the end of the day in a very short period of time. But during each of the sessions, as part of the informal communication and social aspects, we also made sure that there was a break where food and drinks was provided, and they could informally chat, informally socialise with each other. And this particular series of photos I find quite interesting, probably pretty much from any series of workshops that you ran anywhere. But they are in time order. So from the start, you can see very limited interaction during those informal sessions to at the end, where you've actually got quite a bit of interaction going on in an informal setting. So at the end of the first phase of workshops, we did run a short survey, perhaps not as in-depth as we could have done, but we did run a short survey. And the results from that survey were very much demonstrating that they did recognise that they gained a significant understanding about robots, robotic applications and programming of robots, as well as an increased interest in building and programming robots in the future. So they really enjoyed the first set of workshops. And obviously the technical skills were quite obvious. They were able to recognise those quite easily, but the majority of them also recognised the fact that they'd gained skills in some of the other areas. So things like the problem solving, communicating and creative thinking, they all felt as though they'd developed in those areas as well. So although it wasn't a very rigorous survey, we did actually feel we're getting some of that early stage of the socioeconomic technical development that we were really keen to develop. And actually the final result that we had from that survey was to do with teamwork. And out of the 20 participants, 17 of them said that they had worked a lot with other students throughout the course of the development of the robot and programming of the robot. Whilst recognising that actually only 4 of them would normally have worked with others outside of the Robotics Club, and that through the club they'd recognise some of the benefits of working with others to be able to solve problems. And for us, I think that was a really positive result in terms of getting that interaction, collaboration side going. So things were at least working from the first phase of the project. But of course, at the end of the first phase, things had changed, so we needed to actually review and replan for phase 2. The original plan had been to send out a 3D printer and work on CAD design, but that obviously was no longer an option, so we needed to figure out what we were doing for phase 2. And there were various different discussions about what we could do at this stage, ranging from recruiting a whole new cohort and either rerunning the same workshops or slightly different workshops, through to having sort of a partial continuation of the existing cohort where they would potentially be helping to teach and educate a new cohort, as well as also moving on as an advanced group themselves, or just completely keeping the original cohort and continuing on exactly from where we left off. At the end of the discussions, we did decide to continue on with the same cohort. Obviously, if they wanted to drop out, then there's no requirement for them to continue, but pretty much all of them had said that they were very keen and are continuing to push for when we can actually run workshops again. And alongside this, we obviously wanted to, if we continue on with the same cohort, not just have a completely independent curriculum for the second phase, but actually make sure there's a strong connection to it so that we're following through the educational benefits that have been gained from those and building on top of those. And in terms of the hardware that we went for in the end for the phase 2, instead of the 3D printers, we actually decided to go for the Raspberry Pis. So they open up a lot of opportunities. And one of the things we hadn't initially confirmed this when we started phase 2, but we were certainly leaning towards it, is actually being able to connect the Raspberry Pi to the Elegy Robot in order to be able to drive the robot using the Pi as well. But one of the things we were very keen on when we were planning for phase 2 is actually trying to form a stronger connection between the Aberystwyth Club and the Iraq Robotics Club. Having seen how well the children in Iraq got on, we actually wanted to get them to sort of share their experiences. Because during this point, we'd actually been able to get hold of a set of Elegy robots for the Aberystwyth Club as well. And in January 2020, they were starting to work through the exact same worksheets, building the robots. And we thought it'd be really nice to actually get some feedback from the children in Iraq, who were now ahead of the children in Aberystwyth, and get some peer learning going backwards and forwards between the two. So giving tips and ideas for what to do and how to solve various problems. In terms of being able to do that, I should say that we were able to show some of the videos and photos from the children in Iraq, but as I'll say later, we haven't managed to get that connection just yet. So in terms of the hardware for phase 2, we're obviously sending out the Raspberry Pis and looking at the Pi 4. But we wanted to have a little bit of robotic control hardware there to go along with it. And for this, we'd settled on a pan tilt mechanism. So it's actually a expansion board that slots onto the Raspberry Pi on top there. And it's got 2 servos connected in serial to be able to, to be able to control a camera mounted on the top over an angle of 180 degrees in both pan and tilt. On top of that, this white bar at the top is actually a color, a NeoPixel strip, which is obviously programmable and color changing. So we thought that was quite a nice thing that we can actually do quite a bit in terms of color and algorithms there. For our particular application, we've kept it separate from the camera so that we can actually use the lights to track in the camera rather than using the lights to light up what the camera is looking at. But there's lots of different things that they can do with that particular combination of hardware. And the various kit that goes alongside that, including the SD cards for the Raspberry Pi and various cables. And as we expanded to say, yes, we're definitely going to connect it to the Elegy Robot car, then we're also providing an expansion platform. So we've designed ourselves a platform that matches the size of the Elegy Robot and can be mounted on top of it, and then have the Raspberry Pi mounted onto that, along with a battery pack that means it is completely mobile and can be run without connection to the mains or computer. So we've shipped the majority of that out. I should say later edition of the extra components still need to be sent. But otherwise, the shipping this time is actually much simpler. Having gone through the process the first time, the export controls were much easier for a Raspberry Pi than for a robot. Although there were some stock issues that actually delayed us being able to send things out, compounded by political issue, unrest in Iraq, meant that there were quite a few delays to even getting started with phase 2, certainly from their perspective, and delays in the shipping, parcels getting lost, as they do. But they did have eventually arrived, and we will also be shipping out the expansion to be able to connect the Raspberry Pi to the Elegy Robot in due course. But looking now at the educational aspects, what we can incorporate from that time, very much expanding and building on what we were covering in the first phase of workshops. Now, because we're switching programming language for the Raspberry Pi, we're looking at the abstraction of programming concepts and even more strongly at algorithms, so that hopefully they can see the connection between those and help them able to learn other programming languages in the future. And of course, the communication aspects are particularly important. And we were keen to, as I say, actually get the children to become educators for others. So feeding into the Robotics Club, as well as actually helping each other learn. And so some of the exercises that we've got set up were specifically aimed at trying to get different groups to focus on one aspect of it and then teach the others what they'd learned about that aspect. So in terms of the particular workshop schedule, obviously it's the assembly to start off with, and then an introduction to Python programming this time for the Raspberry Pi. And then looking at the NeoPixels and pan-tilt servos and how we can develop algorithms, define different algorithms to produce different patterns. So both in terms of color light patterns with the NeoPixel, but also movement patterns with the servo mechanisms. And one of the things we were doing as part of the worksheets there is actually getting them to write up their algorithms and share their algorithms with others as part of the educators aspect of it. But of course, we don't just want them to do the lights and the motion independently. We want them to connect them together, and so there's the added challenge of trying to synchronize between the two, so understanding how long motion takes and therefore how long you need to have the lights on and so on. And building on top of that, we then move on to the camera, and so this is actually looking at, again, using some of that playful coding, the face tracking, but also potentially looking at color blob detection. So here we're going to be using the NeoPixel lights and trying to track different colors on the lights so that we can actually observe those. And with that tracking, using the servos to be able to actually follow that around as it looks around as it moves around to different places. And that's all entirely done on the Raspberry Pi at this stage. But then after that, for finishing off, we've got the expansion with combining the Raspberry Pi to the Elegy. And so this is the chassis that I was mentioning, with the Pi mounted on top, the battery at the back, and also NeoPixels mounted at the back. And one of the ideas there is to actually try and get them to work together with their various programs to follow the leader. And the hope is we want to try and see how many we can get all going in a loop together and see if we can get them following each other around in a circle. Saying that would be quite a fun challenge for them. But unfortunately, things haven't quite gone to plan for phase 2. So moving on, so we did get the local club set up at the start of January 2020. The club in Iraq was delayed for the shipping, then political arrest, and then of course COVID-19 hit. Unfortunately, it's not possible to give this talk without a mention to COVID-19. We're just about being ready to start running the first series of workshops for phase 2 when Iraq, having just come out of the political unrest and the university reopening, was then locked down again due to COVID. And so we weren't actually able to start the phase 2 workshops. That said, the workshop material is there, essentially available for them. The first series of workshops has all been translated. We do need to ship out the last bit of kit because everything kind of came to a halt. But they will have that and the workshops to go along with that. But we're not going to be able to actually run the phase 2 of the workshops during the project that we've got the funding for. They will have the kit, they will keep the kit, and they'll have the material to be able to run it in the future. And hopefully we will maintain the connection between the 2 workshops to be able to see how they do progress. But that'll unfortunately be where the funding side of things cuts out. So there's limitations in how much follow-up we can do from that in terms of tracking the educational benefits of it long term, as there's also cuts in overseas development aid at the moment. So just to conclude then, we believe that the project in Iraq was certainly mostly successful. They've certainly got a good set of kit and the foundations for running workshops in the future. And the kit that we've provided them, and the workshops we've provided them can be expanded and extended quite substantially over the years. And we do hope that we get many years worth of successful application out of that. And as I say, we will be looking to maintain strong connections with between the 2 clubs and hopefully see how the children develop over the years and what sort of evidence we might be able to collect in terms of the educational benefits of that long term, both in terms of the technical computation innovation side of things, but also the social economic aspects within the area, if we're able to measure that at all, given all of the different variables. So they have got the kit, they've got the material. Unfortunately, we weren't able to run phase 2, and so we don't know how that's gone, but certainly the children who were involved with phase 1 have been regularly asking, when is phase 2, when are we going to be allowed back into the labs to carry on? And so there is definitely a strong desire for them to develop. And we are, now that we've got this essential set of workshops and materials, then we have a template that could be used relatively easily to establish clubs in other areas. And we're certainly keen to see how this can be applied in different areas, both within the UK and overseas, for getting children interested in robotics and programming. Just as a final shameless plug for the Aberystwyth Robotics Week that is coming up in June later this year, we are hoping to hold an in-person event, the Beach Lab, on Saturday 19th of June at the bandstand in Aberystwyth. So COVID permitting, then we will be down at the beach, down in the bandstand with a subset of our robots. It will be a slightly limited set, but we are really hoping to be there in person on the day, welcoming people to talk about robots and showing off some of the robots from the club, talking about the different projects that we've been running, as well as some of the research from the Intelligent Robotics group at the university. During the week, there will also be various talks. So Fred mentioned the BCS talk that we're planning at the beginning of the week on the Monday. And then we'll also have a series of online workshops aimed at different ages. So some introduction to block-based programming for robots, as well as some slightly more sophisticated programming workshops, looking at programming robots at a higher level. So aimed at different age groups and experiences. They will be running online and as live workshops, and also some general activities that they can find on our website, some discussion corners, a quiz and various activity sheets that we hope to make available during that week. So even if COVID does block the bandstand, we actually have a virtual bandstand that will be available, a 3D environment where you can come and interact, really see the models in 3D of the various different robots, and the other content will be taking place online regardless. So thank you very much for listening, and I will take any questions now that you may have.
Oh, thank you very much for that fascinating talk. If I may, I could ask the first question. Did you have any interaction between people in Aberystwyth and in Iraq, or was it all asynchronous?
So the clubs were run asynchronously over there. We didn't have any live interaction, although it was certainly one of the things that we were considering with the connection between the two clubs, whether we could either arrange a time for a live chat between the children in the two clubs, or whether it would be a case of sharing videos. So there was no direct connection between the staff in Aberystwyth and the club running in Iraq, but it was great to see the photos and videos coming out of the different sessions, as well as the feedback. And I have to say, from the short period of time where we were running exactly the same workshops with the children in Aberystwyth, the children in Iraq were actually doing a hell of a lot better than the children over in, that we had here. Whether it was just the novelty of it, but they were really engaging with it and really learning very quickly about the different aspects of it. Whereas I guess the children here were slightly more laid back. They'd had some experience with robots previously, so it wasn't as new and novel for them.
Okay, as I said at the beginning, if anybody wants to unmute their microphone, turn on their video, they're welcome to do so, ask questions. We've had a few comments in the chat. Thank you for this educating and insightful webinar. Thanks, Patricia, the talk was great. Thanks, Fred, Neil, and everyone who helped make it happen. We don't yet have any questions. Does anybody have any questions?
I have a question, Fred.
Go ahead, Neil.
Oh, yeah. Thanks very much, Patricia. I found that really interesting. I appreciate your the pains you had with the sort of MOD, the export license stuff. I've had that in a job in the past. I mean, in terms of the printer, is there any sense that the club could maybe have, if it found finance locally, get it itself to be able to do some of that?
So potentially, yes. One of the major issues we had with the funding was actually, that I didn't talk about, is the transfer of money from Aberystwyth to Iraq. That was basically a no-no. So any equipment we provided, we had to buy here and ship out. There were complications with the transfer of ownership as well, between the two countries and the universities, which caused a few headaches along the way. But thankfully we did get approval just about in time for them to have the robots. If they're able to find money, I'm sure they would be able to obtain a 3D printer directly. It's just not something that we're able to provide for them.
Okay. Thank you. It's a real shame about the funding having to come to a close at this point, isn't it? Yeah, no, I've no bright ideas on that one. So.
Are there any more questions? appears not. Oh, yes, a question. How did you fund the UK operation?
So the funding came through the university as part of this Global Challenges Research Fund, and that covered some funding for staff time involved with the project. Everybody involved was staff at the university, so I guess that covers that part. And then the rest of the funding covered the kit and the shipment of that out to Iraq, which I hope answers the question.
Could I just ask a follow-up one? So you talked about some different kits that you've been looking at and the motivations for which were more applicable to be able to send to Iraq. I mean, I know very little about robotics kits and stuff. I mean, is there a good variety of kits that you can choose from these days, or is there a sort of a core set of platforms that you build things off?
There is an increasing variety of different robotic kits that you can get with a whole range of price brackets to go with them. One of the things that attracted us to this particular kit was the range of sensors that it incorporated at a very affordable price, whereas many of the other kits that were available at the time were actually a lot more expensive or not as complete. But there's an explosion in the market at the moment for different robotic kit, different robotic hardware. And there's a real push for innovation in that. So things like the microbit as well is exploding in terms of kits for that. The other benefit of the Elegy Robot was it was Arduino powered or driven by an Arduino. So it was very familiar to us and what we would be able to do with it.
Oh, they look fun. I like the spinning sensor on the front that looks like a set of eyes looking.
Yeah, I mean, the kids certainly like the appearance of it. It's very easy to attach a face to it, if you like.
Yeah, that's good. That's great. Thank you.
Any more questions? Okay, in that case, I'd like to thank Patricia for a very entertaining presentation, very interesting, some very interesting aspects, and also there's some lessons in how things can be very difficult. Another question, how many hours did it take the children to work right through the lessons you talked about?
Good question. So the phase one ran over 8 workshops. Each workshop lasted, I believe, about 3 hours, but they did have a break in the middle of that. And by the end of that, as I say, they were actually driving the robots, or they programmed the robots to navigate around a maze and follow a line. So that gives you an indication of how quickly they were actually progressing through the material. When we were doing it with the Aberystwyth Club, the sessions are typically 2 hours long, and they were taking slightly longer to even build the robot, let alone try and get to the programming stage. The children over in Iraq were in sort of the 14 to 16 age bracket, so perhaps slightly older than the children that we had in Aberystwyth, who were, but not by much though. I think they were probably 13, 14. So quite similar in terms of ages.
Thank you. Anything else? Okay. Thank you once again, and just remind you that our next event is the BCS Midwest Branch event, is the talk associated with the Robotics Week. That, as I say, that's on Monday, the 21st of June. So look out for details about that. And thank you all for attending. So good. Good night, everyone.